Alrighty then, on this week's episode we're going to continue this block here. I'm going to put these little side bolts in there for this section of the mains. And we will move on to getting some details about rings, ring gap, piston clearance, various things like that. And hopefully you can learn something. You enjoy the video. On these side bolts, you're supposed to use just a little bit of RTV on the head of the bolt. Alright, so the deck of the block, it has been decked by a machine. If you were to look at it under a microscope, it would have these giant peaks that are going all the way across with a bunch of tears. So those giant tears that are in the material are all sticking up, and I'd like to remove those. What I use is a nice newish super scraper. I mean, I've used it a couple times. So I'm going to go ahead and do this and show you how much material this pulls off in one pass. Alright, so I did this center section here. Now obviously I'm going to be missing a lot of area. I'm only contacting basically the middle of the super scraper. You can see how wide it is. And I'm doing this side at this angle so that any of the debris that falls off, it falls this direction rather than into the motor. I've already done this side, but I wanted to show you how much material is coming off. So you can see some of it on there, but it's hard to see on the camera, to be honest, so I'm gonna... There. That's all the peaks and high spots of the metal from the machine work that gets done. And I don't care how fancy the machine is, it's not going to do near as good of a job as a flat piece going across it. You're always going to have peaks from a machine. Hey, you see this? See these little bumps here? Those are where the super scraper, those little lines that are going this way, those are where the super scraper actually took off the high spots. So you can see it's pretty uneven. Even though it was done with a precision machine, it's actually pretty uneven. But I mean, it wouldn't stop it from sealing, don't get me wrong. It's just, I don't know, something about the way it is just bothers me, so I take care of it, I guess. Now we're going to move on to the pistons and rods and assembling those, and then we'll go to ring gap. Okay, pistons, coatings, clearances, things like that. Let's go over a couple of things related to the situation. Now, we have some wrist pins, we have pistons, we have rods, we have piston rings, locks, etc., etc., etc. Let's start with, I don't know, let's start with type of locks. Why not? So there are two different kinds of locks that are used in pistons today. The most common in performance world is what's called a spiral lock, and it is a interesting lock. I had it on a previous video, and they suck. They absolutely suck to install and remove, but there's no way they're coming out. I mean, no way you're gonna have one of those things come out. If you get it in all the way, it's just not coming out. There's no way it's gonna come loose. There's no way your wrist pin is gonna end up sliding over and destroying the side of the block. It's a very reliable lock. Again, suck to install. I can't stress that enough. If you've ever installed them, they're horrible. Let's get into that quick. These ones are the standard spring clip style. These are what's used in most factory applications. These pistons are designed for putting on a factory rod, so maybe that's why they included the factory style locks. I'm not sure exactly. This is the first set of waistcoats that I've had with these that I'm recalling. I mean, maybe I've done them before, I don't know. But this is the first that I recall. I'm kind of happy it has these ears because they're just so much easier to work with. And there's honestly not that much wrong with them. They can come loose if they're installed incorrectly. The reason I'm mentioning that is weight, okay? So your piston, it goes up and down like this, and if your lock is like this, now if it's going up and down this way, as it goes up and it has to transition back down, it's going up and all this momentum in this lock is going up, and then as it comes back down, it squishes a little bit and then goes down, okay? When it does that, there is a very, very slim chance, but a chance nonetheless, that it could squish enough or wear out enough that it starts to squish enough to come out. When you install these locks, it is absolutely necessary that you always position the gap in them either up or down. Most likely it's going to be down. You see this tab here, this little notch that's in the piston? That is for the sake of removing these. So in the event of you're rebuilding your motor you would take something like a pick, you would shove it in there, and you would pry like that, and it would pop it out of there, okay? And therefore, you want that gap to be down here where my thumb is, so that you can easily pry at the very edge of that tang and get it out of there if you need to get it out. So that's the locks. Pistons and coatings and clearance are kind of related. If you have an uncoated piston and you floor it going down the road, this piston heats up pretty quickly, okay? Every time it fires, it heats up. And it gets cooled down by the oil on the underside, along with a little bit of the skirts transferring heat to the cylinder walls, but they create, I don't know, it's, that one's kind of sketchy. That one's, I'm not sure about. But the flame front that hits this is extremely intense, extremely hot. Every time it compresses the gases, all those gases heat up while they're compressing, and they transfer heat as well. If you have a coated piston, it will transfer less of that heat during that instance on this side, but it will transfer the heat to cool it down through the oil still normally as fast as it would on this side. So you still have the same amount of cooling, but less instant heat flashing the top of this piston. With that, you are capable of running a tighter cylinder wall bore clearance if you desired. I guess it would depend on the circumstances. Of course, these are details that get into really, really sketchy territory. I'm not saying that you should lower your piston to wall clearance because you ceramic coated it. It totally depends on the application. If you're running a lot of power and you ceramic coat it, you don't want to decrease that clearance unless you're in some kind of crazy competition, bracket racing, whatever, where you have very limited amounts of things you can do and you're trying to maximize everything. If you're driving the vehicle on the street, don't even dare messing with the piston to wall clearance unless you really know what you're doing. Just make sure you have enough. More is better for reliability and not having a problem down the road. Tuning also plays a big factor in that. If you have a crappy tune, more is going to save you, less is going to hurt you as far as clearance goes. This motor, because it's not boosted, it's not upgraded in much ways other than airflow. You know, we got cam, ported heads, things like that. This motor, I did have them set the piston to wall clearance just a little smaller than what they say is 20 thousandths over, so it's just going to be just an ever so slight hair smaller. I'm not going to tell you the number, but it's just a little bit closer. And the only reason I did that is because it's not boosted, and I'm trying to maximize the leakage, the blow-by, the amount of contact the heat has with the rings, etc. So the less flame that hits that ring and the less leverage that flame front has to push on the edge of the ring, the better for sealing, the better for various reasons. However, it's also getting dangerous unless you really know what you're doing. Here are the piston rings. They come with a sheet, and that sheet goes over ring gap. It's pretty much the same no matter what you do. So you see this little thing here, it's got the oil ring in it. There's several types of oil rings, but this is the most common you'll ever see. It's just a I don't know, waved, smashed piece of tin, and then you have your two scraper rings. This is an oil control device, so that controls the oil on the piston. Okay, so here's that sheet I'm talking about. Gives you a minimum gap per inch of bore, and this is all based off recommendation. And like I was saying, the clearances all depend on your performance level and what you're doing with the engine. So they give you all that info right here, and these are pretty safe guidelines. If it's going to be a sketchy tune, if it's a carbureted vehicle, so you have a chance of having an issue there, more so chance. I mean, fuel injection still has a chance of a problem. But you're going to want to go, maybe one notch higher on the performance level if you want to be safe. But if you want to maximize performance, do what they recommend, unless you know enough to know better. So they give you high performance street strip. So this would be kind of a basic, what this would be, I guess. they say top ring bore, and this is per inch of bore, 0.0045, and then second ring is a little bit bigger. Now the second ring always has a slightly bigger gap, and they do that to prevent ring flutter. And the ring flutter happens if you have a big gap on the top ring, and this looks like a nape here, bottom ring, I'll look in a minute. If you have a big gap here and a small gap here, the pressure from the cylinder is going to go down here and it won't be able to escape this area, and it's going to push this ring up along with the pressure pushing down on it, and this ring is going to flutter. It's going to cause problems. This ring is going to have a bunch of pressure against it. That's not good either. The piston design, there is a bunch of lines in the Weisskos. I'm not sure their purpose there, but I do like that Weissko puts their top ring down a little ways, and the reason I like that is because it keeps the ring away from the heat. See how far that is down. I can go grab a stock piston quick. Now for comparing sakes, I'm going to line the rings up, the ring marks up, and then I'm going to show you. Look at the difference. So those ring marks are lined up, but there's a lot more material on the aftermarket piston above that ring mark. So that helps with keeping the heat off the rings. It also offers a little bit of a disadvantage. This thing is having a little bit of spent gas in it, and that gas will not burn, but it does compress, so it's kind of a loss of power in that respect. But it's so minor and so minimal. When it comes to a performance application, I'd much rather have the extra room for the safety factor. Now these pistons are a domed piston, slightly domed. This is just what was available for fitting the stock connecting rod in a Weissko that I had as an offer to purchase, and I thought I can make up for whatever difference with the head gasket, which isn't the best. Now the best piston design is a flat top piston because of airflow characteristics within the chamber, the burn factor within the chamber, things like that. It makes it easier to clean off. There's all kinds of reasons that a flat top piston is the best design, but this will work all right. It's not going to have any kind of problems. When it comes to these pistons, a lot of times they have sharp edges on them. Weissko is usually pretty good about removing those sharp edges, and this one I didn't have to mess with. That's one thing that I usually do before I send it in for balance, is I can take care of any edges. And yeah, that's pretty much all for now. What I'm doing right now is I'm marking the ring. So I did the first one. I took extra time to make sure I got it just right. And then I look at the gap between it to get a good idea. And I mark the next rings for the minimum I need to remove. That way I can get close to having it the right measurement on the first try, and then just have to touch it up a little bit after that. Kind of an eyeballing, unusual technique. I don't have a fancy ring filer that can do exact measurements every time. A little bit of ring positioning top. So the compression ring, the top ring, and the second ring, and then the oil ring. The oil ring, I have the slots opposite here. There's no particular reasoning for that. Just, I guess, no gap where the oil doesn't get scraped. I don't know. But the second ring is mostly an oil scraper, more than anything. And I position it so that the gap is on the exhaust valve area. And then the top ring I position on the intake valve because that's going to be the coolest area. But I don't want to try and position it here. Most likely they're going to move, so it's probably not going to matter. But in case they did stay, it would be nice if it's positioned just a little bit. So you want to kind of go just offset. So I'm lining up second ring here, top ring here. You don't want to line them up here because when it first fires up, if there was some kind of weird sharper edge here, even though you deburred it, it will cause a nasty gouge on the thrust side while it's going up and down in the cylinder. And that gouge is obviously going to lose compression and cause oil and everything else to come past it. So position the rings decent and it won't be a problem for you. Now I'm going to go ahead and get this cap off of here and put the first one on, and then we'll just continue the process and go through all of them. If for any reason the piston stops going while using one of these crappy piston ring compressors, there's going to be a ring that's sitting outside of its little spot that it needs to go in, and you need to be sure you get it in there before you continue, because you don't want to fold it over, especially the oil rings. They are particularly easy to screw up. So on the last week's episode, I guess we'll call it, I talked about different things on that bearing plastic gauge situation. This one I'm going to cover not plastic gauge, though I am going to use it, and you'll see a little fast forward of it. I'm going to cover a couple things on these bearings. These are Clevite bearings. They're a coated performance race bearing. There's two different sizes here. These are both for standard ground crank because this one did not need the rods ground down, or the rod surface here ground down. But they are two different sizes, however. They are both for the standard rod or standard journal size, but they are different in the respect of one has a extra thou of clearance. And the beauty of that is that you can get the desired oil clearance you want. Usually I end up using the extra clearance bearings the majority of the time, the vast majority, because I like to have a little bit of extra cushion for a little bit thicker oil because of performance application situations. Now this one, I'm cool with it being a little tighter, but I'm going to start with the extra clearance bearings, and you can mix. The nice thing is you can mix and match these. So if I say I put the extra bearing clearance in one rod and I put it on top and bottom, use both extra clearance bearings, and I end up with a half a thou looser than I want it to be, I can swap out one of those bearings that's a thou loose, or one of those bearing halves that's a thou loose, with one that is the standard size, and I'll gain that half a thou that I need to gain. So whichever direction you need to go, you can kind of go back and forth between the different sizes and make it work. So that's why I have both sizes. There is an upper and lower on these. It's not as critical with stock rods and a stock crank because the whole purpose of it is a chamfer on the crankshaft itself on the bearings, and it's to avoid the chamfered side of the crank so that the bearing doesn't interfere with it. It would not have a problem on this, but still put it on correctly, please. So I am going to go ahead and put the extra clearance one on all of the pistons that I put in, and then I'm going to flip it over. I'm going to take stuff apart. I'm not going to torque it, put it together the first time. Take stuff apart and go ahead and check all the clearances after I wipe all the oil I just put on there on, because you don't want to be rotating this thing without any oil. It's going to be a little harsh on it, especially if there happens to be one speck of dust in there. So I ran into a dilemma. The rod that was replaced, I did not notice because I hadn't taken the bolts out. The guy at the balance shop didn't think about something. I suppose it's due to the situation. I was there and I asked him he could just check the balance of it when I brought it to him or whatever. And he didn't even swap the bolts out, didn't even think to. These are the ARP rod bolts. The number was supposed to correlate. There's a definite difference. The factory bolt is significantly shorter. Well, this is interesting. So that bolt will work in these rods. These rods have a rusty spot because of how short those bolts were. I don't know where this rod came from. It's obviously a remanufactured rod. Now, it's not threading because the threads were untouched before and there's a little rust in there. So maybe this was from a flood motor. It's hard to say. But if I can find the right tap, I can clean those threads up, and then I just have to have the rod rebalanced. So that's not going to be the end of the world. So I'll go ahead and see if I have a tap that can just clean out those threads, because I don't want to wreck the threads on the rod bolt, and I don't want to have incorrect torque due to there being a friction at the very end of the thread area. Wow, that was interesting. So, I learned something. You got to learn something today, quick, and I'm going to share my learning experience with you. I ran all the way to the shop, okay? This is, I don't know, 14 miles away. So, I drove all the way to the shop that does the balancing. I get there, and he's doing it right in front of me. He's throwing it on his equipment. And what I need to share with you, just because I learned something and I thought it was pretty cool, was how he goes about checking the balance. So when he's checking the balance of these things, he compares end to end, okay? And that's what he can calculate what the rotating weight is, because this is more the rotating weight than this is, but it all plays a part in when it turns and the leverages, and I don't know anything about that part of it. I just know it's pretty complex how they get their weighting figured out. But how he weighs it is what I got to see, and I went all the way there to find out that this is actually measuring exactly the same with the different rod bolts. Kind of funny how that worked out, but I think it has something to do with the fact that it's hollow on the end here. The head of the bolt here is smaller than the factory bolt, and the shaft area where the threads are not does not have that little collar in it. So all that adds up to the extra 1/4 inch of length worth of material here. It makes it weigh the same. But nonetheless, I'm going to show off my awesome artistry skills here. We're going to draw you a picture. Alright, for any of you who might get jealous early, you might want to leave this video because I'm going to show some pretty awesome artistry skills. You're totally going to be jealous. Here we go. Alright, so how he does this is, say, this is his scale. And then there is a beam that comes off the back of that scale and goes up, and it has a digital readout. Let's pretend it's 250 grams. We'll just throw a number in there. Okay, we'll just pretend that's the rod weight. I didn't look at the paper. I got it sitting over there. Anyway, so he has the scale, and then on the scale there is this contraption that he places up there for the rods. And this contraption has these little legs that stick out and support it. And then in the center of this contraption, right about here, on the top, there's a bearing system. And then from there, there's an additional bar that hangs down and has a bar across it like this with 2 little bearings like this, okay? And so this is like a counterweight, and this is like where you hang the rod from, like this. So the rod sits there like that, and on the other side here, he has this other contraption. It's a big arm that goes up, and then it has these little feet that come out. God, you're so jealous of my artistry skills right now. I know you are. Sweet, huh? Then there's another arm here, and this arm has this chain link that comes down, and another chain link that comes down, and that goes to another mechanism with a bearing on it. And what he does is he hangs, well, it's precision artistry here. It hangs, he hangs it level is what he does. And the bearings are so that it automatically self-centers, and then the cables have a little bit of slack too, for the chains, and he can move this according to the length of the rod. And then he gets his weight on the end that way, and then if he needs to do the other end, the situation flips over. You know, he moves the things around, I'd imagine. He didn't do that part because he was just checking this since that's where I changed the bolts. But I thought it was really cool how he has this interesting mechanism where it's got a bearing for a bar, and this bar that's riding on this bearing like this has another two sets of bearings that are specifically for placing this into. And I just kind of thought that was cool and be fun to share. And that's how he gets his weights on the rod end. Now, I didn't ask him, I probably should have just out of curiosity, how he does the pistons, because I'm pretty confident he does, like I said in last week's episode about the front to back of the piston, or side to side, of however you want to say it, for the wrist pin, for the weight this way. I'm pretty confident that he does balance them that way, because I've noticed he always tends to grind one side more than the other on different jobs. And so, you know, I pictured it as if he had a scale. Say this is the scale base. Wow, that's perfect. If that was the scale base, that he had like maybe a hook sitting here, and he just hanged that end of the rod on the hook and set this end down on the scale, is all I pictured it as. I didn't think it was so precise as to having the two bearings riding on the inside of the rod to make sure that it stays centered all the time. Let's continue on with the video and get to putting this back in that I removed for apparently no reason other than to be sure that it wasn't messed up, but I'd rather be safe than sorry. Now, being that this is the last bearing I'm installing, I'm going to leave it dry since I won't have to turn the crank, and I can check these back two first. Okay, so I'm not sure what happened to the previous one. It was at 1.5 thousandths, but my video stopped recording or something, I don't know. Maybe I just ran out of time on that video. Anyway, so I'm checking this one, and it is at 2 thousandths. That is too loose for this particular build. So now I get to actually do the half bearing thing, where I put a standard bearing mixed with a extra thousandths bearing to get my desired 1.5 thou that I want to get. Okay, so according to this, it is where I want it to be. It's just about 1.5 thousandths, maybe 1.5 or 1.6 instead of 1.5. So just a little more, but that's fine, perfectly fine. So I'm going to go ahead and just leave them bearing set, that mix match bearing set in there, and it will work out perfectly great. I'm going to go ahead and get this cam installed. I have all the bearings taken care of. I don't know how much I got on footage, but the bearings are clearanced properly now. I had several that I had to change out. I had 2 of which that needed to be standard bearings all the way. Both bearings needed to be standard. I had 3 of them that needed to be half and half, and then the others were the extra clearance all the way. Alright, we are set pretty much on almost having the short block done here. I still have to do a few things. Obviously, I gotta get the windage tray. There we go. The windage tray, the oil pan, that kind of stuff on here. I got a few things to do yet. Not much though. I can start doing all the covers and things of that nature. Throw the lifters in. The lifters are still soaking in the oil. I might as well just leave them in there. You saw me torque pretty much everything on here. Yeah, so there you have it. There is a short block pretty much assembled. So that's going to bring us to the end of this episode here. And I hope I get to see you next week on the next episode of the C5 or C6. It's a C6. Wow, can't believe I just said that. The C6 is a 2005 C6 engine build job that we're doing. And I got to talk to the guy about his head gasket now. And we got to figure out what we're going to do as far as a compression ratio. I want him to put a standard size gasket in here, a little bit thinner gasket than the compression ratio he'll acquire or that he had previously. So he had previously at flat tops. These are going to increase compression a little bit unless we go with a thicker gasket. With that in mind, I'm hoping that I can have him go with the thinner gasket and increase the compression because he runs E85, and then we can get a tune done and get just a little bit more out of it than what he was already getting out of it. So this thing will definitely take it, and I hope he can get another 100,000 miles out of it because he's got 108 on the bottom end previously, and now he's got better quality bearings and better quality pistons, rings, probably better machine work because the factory machine work sucks. And all he'll have to do between now and that 100,000 miles is change out his springs a couple of times, his valve springs, because of the lift that the cam has on this particular motor. Aside from that, this thing should hold up for years to come and thousands upon thousands of miles to go. If you enjoyed this episode, don't forget to hit that notification bell. If you like seeing more of these, if you want to continue the series, I will be doing a project every Friday. I will be posting a new project. I've decided to dedicate everything to Fridays. And every once in a while I'll throw in a little bonus video. And I'll just pick a random day of the week to do that. It'll be smaller stuff. I'm going to try and, as much as possible, keep the projects like this where they're more performance oriented for the week-to-week Friday thing. And yeah, let's make a routine out of how this is going. I think it'll go well. If you think so too, don't forget to slam that like button down below. I appreciate every one of those I get. So thank you for watching, and I hope to see you on the next episode of the 2005 C6 Corvette engine build.